Hi, this is Alex from devstories.eu. Zipline Backtesting Engine, Episode 7 of 7. You spend months perfecting an algorithm in a simulator, but the real market does not accept simulated trade orders. Zipline was designed primarily for backtesting, but its modular architecture means you can completely bypass the internal simulation and route directly to a real execution engine. Extending Zipline architecture makes this transition possible. Out of the box, Zipline operates as a closed loop. You feed it historical pricing data, it calculates signals, and it matches your orders internally against past market behavior. The system intentionally isolates your algorithm from external networks. But a modern trading system eventually needs to talk to the outside world. You need a way to swap out the internal simulation components for custom modules that handle live data and real capital. Zipline handles this requirement through an extension mechanism built around a specific initialization file called extension.py. This file acts as a local registry for your environment. When the Zipline framework starts, it immediately looks here for user-defined overrides. You use this file to register new data bundles, custom commission models, and alternative execution engines. The most critical component you must swap for live trading is the blotter. The blotter acts as the internal order management system. It tracks open orders, cancels them when instructed, and processes trade fills. The default simulation blotter pretends to execute trades based on historical volume and slippage algorithms. To trade live, you must bypass this entirely. You achieve this by writing a custom blotter class. Instead of simulating execution, your class methods make network calls to a real broker API. When the algorithm requests a trade, your custom blotter formats that request into a live order and transmits it to the exchange. Here is the key insight. You do not modify a single line of the original Zipline source code to implement this. You define your custom blotter class in your own workspace. Then you open extension.py. You import the blotter registration function from the Zipline utilities module. You pass this function a unique string name for your broker, along with your custom blotter class. That registers your execution engine globally. Finally, when you execute your trading script from the command line or a notebook, you simply provide the string name of your custom blotter as a launch parameter. The framework swaps the internal machinery automatically. The exact same algorithm that ran in simulation is now trading live capital. Supporting this level of modularity requires a highly stable core foundation. Zipline relies heavily on fast numerical data frames and relational database storage to move information between the algorithm and the blotter. With the release of Zipline 3.0, the core architecture received a significant structural update to modernize this foundation. The entire platform was migrated to support Pandas 2.0 and SQL Alchemy 2.0. Upgrading to Pandas 2.0 brings substantially better memory management and faster execution times for the massive time series arrays that Zipline processes on every tick. SQL Alchemy 2.0 completely modernizes how the engine interacts with underlying SQL databases. It enforces stricter, more explicit query execution paths when the system manages asset metadata and stores trading results. These foundational upgrades ensure that whether you are running a massive historical backtest or routing live orders through a custom broker extension, the engine operates on the modern standard of Python data infrastructure. By separating the trading logic from the execution mechanics, the architecture guarantees that your algorithm remains completely untouched while the underlying execution layer adapts to reality. I highly encourage you to explore the official documentation and try writing your own extensions hands-on. If you have ideas for what we should cover next, visit devstories.eu to suggest topics for our future series. Thanks for spending a few minutes with me. Until next time, take it easy.